So as we begin section 10.8 here in algebra, finishing up the chapter, we're looking at comparing linear, exponential, and quadratic models, all of which we've discussed in class over the course of second semester. So just a quick review here. Obviously, the three graphs of each are shown. Okay. One thing we should note is that a linear function is given by the equation y equals mx plus b. Okay, and that goes back, that's middle school stuff that you already know. Slope-intercept form y equals mx plus b. Okay, an exponential function has the form y equals a times b to the x power. Again, something else that we've discussed already in this class. And finally, a quadratic function, as we all know, is y equals ax squared plus bx plus c. And the graphs are also shown just to kind of refresh your memory. I think the one that might be the most obscure to all of you is probably the exponential. And so there it is. All right. So the couple different things we're going to do here in this section. The first is we're going to look at how to identify whether it's a linear, exponential, or quadratic based on a graph. So as we go through here, we have a set of points, and we're just going to plot those points. So negative 2, 7. So let's see here. 1, 2, 1, 2, 3, 4, 5, 6. Should be way up here. A little bit off there. Negative 1, 1. Should be that point. 0, negative 1. Right there. 1, 1. And then 2, 7. And I think it's pretty evident now when I connect these dots that that U-shaped graph, which we call a parabola, represents a quadratic function. Okay, so this guy would be a quadratic. As I look at part B here, again, just plot your point. Negative 2, positive 4. I have negative 1, 2. I have 0, 1. I have 1 and 0.5, and then I have 2 and point. So something like this, and then we connect the dots. Alright, so our graph looks something like that. Obviously, looking at that graph, it's not a line, it's not a parabola, therefore this thing is an exponential. Alright, and then finally, the third example, I'm going to let you guys go ahead and do that on your own, but it should work out to be a linear function. Okay? Alright, so now the next thing that we're going to look at is we're going to look at how to determine whether or not something is exponential, linear, or quadratic based on the table of values that we're given. So as we look at part A here, the first thing to note is that the x values all increase by 1 each time. Okay, so that's the first thing you want to take note of. The second thing is now we'll look at the differences. So in other words, to go from negative 12 to negative 8, add 4. To go from negative 8 to negative 4, add 4. Negative 4 to 0, add 4. 0 to 4, add 4. Since these are all consistent, plus 4, plus 4, plus 4, plus 4, that tells us that this thing is a linear function. Okay, so if that first time that you look at the differences, they're all equal, then that tells you it's a linear function. Okay, this next example, again, note all your x's jump up by 1 each time in your table of values. Now you'll notice here first when you look at the differences, you're going to say, okay, here add 12, here add 4, here subtract 4, and then here we have to subtract 12. Okay. Now what we're going to do is we're going to look at this, what's called the second differences. Okay, in other words, we've already subtracted them once. Now let's go ahead and subtract them yet again. Okay, so if I subtract 12 minus 4, that's 8. 4 minus negative 4, that's also 8. Negative 4 minus negative 12, okay, so it's plus 12, that's also going to be positive 8. Now if your second differences are all equal, okay, then that tells you that this thing is a quadratic. So if you subtract once and they're all equal, it's linear. You subtract twice and they're all equal, it's a quadratic. Okay, and then an exponential is going to be a little bit different. You're going to notice here in part C, and you can kind of use, and I don't know off the top of my head if actually part C is in fact an exponential. I believe it is. But let's go ahead and take a look. All right, so in part C, as we look at our differences, again, first note, you jump up by 1, by 1, by 1, by 1. That's good. Okay, so when I subtract negative 0.25, negative 0.5, negative 1, negative 2. Okay, and then you can even go ahead and look at your second differences if you wanted to. You'd say, okay, when I subtract those two guys, I get 0.25. When I subtract these two, I get 0.5. Okay, well, since these two are not the same, let me go back and rephrase this. Because all of these were different, that means it's not linear. And because these guys are not the same, that means it is not a quadratic. Now, you can't just go ahead and say, okay, well, if it's not linear, it's not quadratic, then it has to be exponential. That's not true. Maybe the table of values does not represent a function. And so what you have to do is you have to go through now and recall that if it's an exponential, then that means that the ratio is consistent. Okay? In other words, when you look at 0.5 divided by 0.25, you get 2. When you look at 1 divided by 0.5, you get 2. When you look at 2 divided by 1, you get 2. When you look at 4 divided by 2, you also get 2. So since all of these ratios are 2, that tells you this thing has to be an exponential. Okay, and that's the long and the short of this lesson. Okay, so you're looking at differences. If you don't find any consistency within your differences, then you go ahead and start looking at ratios. Okay, I'll do the next 3. I'm going to do them quickly. My encouragement to you would be to pause the video, work through those 3 examples right now, and then use the video to check your understanding and make sure that you're on the right track here. Okay, went up too much. All right. So for part D, this difference is -3. Actually, I take that back. We have to add 3. Add 3. Add 3. Add 3. Good news. This guy's linear. Makes our life easier when it's linear. Okay. Part E goes up by 1, by 1, by 1, by 1. That's good. When I look at these guys, I have to subtract 24, subtract 6, subtract, what was that going to be, 1.5, and then we're going to subtract some nasty number. Okay. I'm actually going to pull out, actually it's 0.375. All right, and then I think our initial reaction here, well, first of all, we know it's not linear. Okay, now let's go ahead and look at those two. When, let's see, to go from -24 to -6, I have to add 18. To go from -6 to -1.5, here's what I do know. I don't know exactly what that is. I don't need to. I know that it's not going to be 18. Therefore, I know that this thing's not a quadratic. Okay, so I've eliminated linear. I've eliminated quadratic, and so now I'm going to go ahead and just verify and see if this thing's an exponential. All right, so when I look at 8 over 32, I get 1/4. When I look at 2 over 8, whoops, I get 1/4. When I look at 0.5 over 2, I get 1/4. And when I look at 0.125 over 0.5, I will also get 1/4. All right, so since all of the ratios are consistent, that tells me this guy has to be an exponential. Exponential. There we go. And finally, in part F here, as I go through, again, first verify 1, 1, 1, 1, so we're good there. Let's see here, to go from here to here, subtract 15, subtract 5, add 5, and then add 15. And then you look at your second differences. Okay, to go from -15 to -5, add 10. To go from -5 to +5, add 10. To go from +5 to 15, add 10. And since all of my second differences are the same, this guy has to be a quadratic function. Okay, so that's what we're doing when we're comparing these types of functions. You can look at graphs or you can look at table of values. So as always, questions regarding this stuff, bring them to class tomorrow and we'll take those first thing.